Greetings everyone. Welcome to today's presentation. We are here to introduce a highly important and beneficial technology called auto-tiering. This technology plays a crucial role in the field of data storage and management, bringing significant improvements in performance, cost savings, and optimized data access speeds. SSD offers high performance, but at a higher cost per GB compared to traditional hard drives. All SSD configurations are not practical for most applications, as only a small portion of data requires SSD. Balancing performance and cost, a hybrid storage architecture with a combination of SSD and HDD is a reasonable approach. Generally, allocating 10 to 15% of storage capacity to SSD is sufficient for critical high I/O applications. Automated tiering pools dynamically match storage requirements with data access frequency. Auto-tiering must have 2 tiers at least. Automated tiering pool segregated disk drives into 3 categories for dual controllers. Tier 1. Choose SSD tier for storage when fast response time and high performance are crucial. SSD utilize flash technology, eliminating rotational latencies and delivering significant performance improvements and energy savings. Although SSD drives have a higher cost per gigabyte compared to traditional spinning drives, their per I/O cost is lower. To maximize efficiency, utilize SSD drives for data that requires fast response time and high IOPS. Auto-tiering optimizes the utilization of these high-performance resources by automatically moving hot data to the SSD tier. Tier 2. Utilize SUS HDD tier for a balance of performance and capacity. This tier offers high levels of performance, reliability, and capacity by storing data on fast rotating disks using mechanical hard disk drive technology. It includes 15K and 10K RPM spinning drives, which provide consistent response time, high throughput, and good bandwidth at a moderate price. Tier 3. Choose NL SUS HDD tier to lower the cost per GB of data. This tier consists of 7.2K or lower RPM SUS HDD that prioritize maximum capacity at an appropriate performance level. While NL SUS HDD have slower speeds than SUS HDD, they significantly reduce power consumption and increase capacity in higher performance storage tiers. In a typical system, most application data has minimal I/O activity. Due to their lower cost per GB, NL SUS HDD are suitable for storing cold data. They consume less power than SAS HDD and improve total cost of ownership, considering both purchase and operational costs. In statistic stage, the volume space is divided into equal size units called sublong, where the hotness is collected and analyzed hourly. The activity level of a sublong is determined by counting read and write accesses. The logical volume manager maintains a cumulative I/O count and assigns weights to each I/O based on its recency. Newly arrived I/O are given full weight, which gradually decreases over approximately 24 hours. The weight reduction is processed hourly by our precision algorithm. This continuous statistics collection happens in the background for the auto-tiering pool. In ranking stage, this analysis produces a rank ordering of each sublong within the pool. Note that the policies of volumes would affect how sublong are ranked. In relocation stage, according to hotness analysis, data relocation occurs within a user-defined relocation window. The relocation process stops when the window closes. The relocation rate parameter determines the speed of the process. Auto-tiering promotes sublong to higher tiers based on a candidate list created during analysis. It prioritizes relocating sublong to higher tiers, ensuring higher performing drives are utilized. Data is moved to higher tiers during I/O if space is available and the tiering policy allows. 10% of free space is reserved in all tiers for new allocations of higher priority sublong. Lower tiers are used for capacity as needed. The relocation process is automated based on the user-defined schedule or can be manually triggered. Auto-tiering improves sublong placement in a pool. For the best performance in various environments, auto-tiering has a completely automated feature that implements a set of tiering policies. Tiering policies determine how new allocations and ongoing relocations should apply within a volume for those requirements. Auto-tiering uses an algorithm to make data relocation decisions based on the activity level of each unit. It ranks the order of data relocation across all volumes within each separate pool. The system uses this information in combination with the tiering policy per volume to create a candidate list for data movement. We support 5 tiering policies. Auto-tiering. Start highest, then auto-tiering. Highest available tier. Lowest tier. No data movement. Auto-tiering. This is default policy setting. It allows moving a small percentage of the hot data to higher tiers while maintaining the rest of the data in the lower tiers. This policy automatically relocates data to the most appropriate tier based on the activity level of each data. Sub-long are relocated based on the highest performance disk drives available and its hotness. Although this setting relocates data based on the performance statistics of the volume sets with highest available tier take precedence. Initial space is allocated in the tier which is healthier and has more free capacity than other tiers, then relocated according to hotness of the data. This is the recommended policy, and it is the default policy for each newly created volume. This can be used in a large volume of storage structure. Usually, the user does not know how to put the data to the right tier. It is entirely handled by the storage system. By default, the data will be relocated at midnight. At this case, hot data calculations take a long time to accumulate and move up, and a few fixed blocks require extreme high performance. Using this policy will have a significant effect. Start highest, then auto-tiering. This takes advantage of both highest available tier and auto-tiering policies. Start highest, then auto-tiering sets the preferred tier for initial data allocation to the highest performing disks with available space, and then it relocates the volumes data based on the performance statistics and the auto-tiering algorithm. With this tiering policy, less active data is moved to lower tiers, making room for more active data in the higher tiers. Initial space is allocated in highest available tier first, then relocated according to hotness of the data. This can be used for hot data in a short time, such as video editing. The new coming films are often edited at the beginning. After the editing is complete, the files are not always used and eventually moved to the archive. In this scenario, you need to understand the capacity of the hot data and prepare the capacity of the SSD tier. Then this policy can maximize the efficiency. Highest available tier. Use this policy when quick response times are a priority. This tier is effective for volumes which require high levels of performance whenever they are accessed. The policy starts with the hottest first and places them in the highest available tier until the tier's capacity or performance capability limit is hit. Then it places the sublong into the second higher tier. Initial space is allocated in highest available tier. Auto-tiering would prioritize sub-LUN with highest available tier selected above all other settings. This allows users to allocate resources in a timely manner. Assuming that some volumes will be frequently accessed tomorrow, the IT administrator can manually adjust to this policy. As a result, the data will be relocated to the highest available tier at midnight. In this case, you can get better efficiency under the same resources. Of course, the premise is that the capacity of the volume needs to be controlled. Lowest tier. Use this policy when cost effectiveness is the highest priority. With this policy, data is initially placed on the lowest available tier with capacity. Select this policy for volumes that are not performance sensitive or response time sensitive. Regardless of their activity level, all sublong of these volumes will remain on the lowest storage tier available in their pool. Data of volumes with lowest tier policy would always reside in the lowest tier. Changing policy of a volume with data in higher tiers to lowest tier would cause all its data in higher tier to be relocated down to the lowest tier. It is for the purpose of data backup, for those volumes which do not need the performance, and the need for large capacity storage of data. It can be set to this policy. No data movement. If a volume is configured with this policy, no sublong provision to the volumes is relocated across tiers. Data remains in its current position but can still be relocated within the tier. The system still collects statistics on these sublong after the tiering policy is changed. Initial space is allocated in the tier which is healthier and has more free capacity than other tiers. no relocation would be performed in a volume which selects no data movement tiering policy. This should be least used. The data in the volume using this policy will not operate any hotness analysis. It is suitable for infrequently used data. This table summarizes the tiering policies. You can choose the right policy based on your application. Or you are unsure, it is recommended to use auto tiering policy when creating a volume, and the relocation schedule remains in daily. Then observe the usage of every volume via the performance monitor for a while, and then set the required policy for each volume. The SSD cache and auto tiering solutions can work together and complement each other. A key difference between tiering and cache is that tiering moves data to SSD instead of simply caching it. Tiering can also move data both from slower storage to faster storage and vice versa. However, SSD cache is essentially a one-way transaction. When the cache is done with the data it was accelerating, it simply nullifies it instead of copying it back to HDD. The important difference between moves and copies is that a cache does not need to have the redundancy that tiering does. Tiering stores the only copy of data for potentially a considerable period of time, so it needs to have full data redundancy like RAID or mirroring. Total storage capacity in auto tiering is a sum of all individual tier capacities, whereas in cache, the cache capacity does not add to the overall slower storage capacity. This is one of the key differences. In addition, SSD cache affects rapider than auto tiering, because auto tiering will be affected by relocation the data in a period of time. So SSD cache warm-up timeframe is usually minutes/hours, whereas tiering warm-up is usually days. SSD cache is used for highly frequent data access environments and is effective short-term, such as virtualization or video editing applications. However, auto tiering is used for predictable I/O workloads and is effective in long-term. It's suitable for web, file, or email server applications. This table summarizes the SSD cache and auto tiering comparison. It is very easily to create auto tiering pool. Please notice to select the different disk type HDD and SSD here. If you only select the same disk type, the auto tiering option would be gray out. Here can see there can be set different RAID type for each tiers. In this case, there are two disk type HDD and SSD, so the tier quantity is 2. In the following pool configuration, user would only need to set volume size and select host group, and the auto tiering pool will be created and user can start to experience. As previous mentioned, the volume default tiering policy is auto tiering. If user needs to adjust the policy setting, you can enter volume property page and select the tiering policy you need. For other volume setting, we are using the best performance configuration. You need to gain the highest performance. Please remain the other volume setting as default. As the relocation process we mentioned, this function will relocate the data after doing analysis, but this allocation process will affect the current I/O performance. So we would suggest scheduling relocation process to the off-peak time. Here, you can select the suitable relocation schedule policy. The default relocation rate is fast. This means the relocation priority will be higher than medium and slow. If you don't want relocation process to affect the current I/O performance, you can adjust it as medium or slow. During the auto tiering taking effect, you can also monitor all tiers' capacity and move in between each tier's information. First, this feature is license required. You can submit our trial license for 30 days to experience the higher performance by this function. Second, if you are doing disk roaming to move the pool disks, which is enabled auto tiering to another chassis. In our auto tiering design, it is based on the chassis. So please make sure another chassis is also enabling auto tiering license before you are doing disk roaming. Third, in the SSD cache vs. auto tiering section, we know that the effectiveness of SSD cache can be seen in a short term, and auto tiering is effective in a long term. Both functions can be used at the same time and achieve complementary effects. Be noticed that the quantity and the capacity of SSD which SSD cache and auto tiering use, an IT administrator should adjust via the performance monitor at any time to get better. With auto-tiering technology, the X-CubeSand series can help you put the right data in the right place at the right time for optimal use of all storage tiers and allow you to reduce storage costs and management overhead while increasing performance and capacity. Intelligent algorithm behind auto-tiering manages the data relocation and monitors the data hotness ratio using half-life coefficient and advanced ranking mathematics. Relocations can occur on the user-defined relocation schedule, making auto-tiering a truly automated offering.